This is how training actually works, not the inspirational version, not the part where the machine learns as if it were sitting in a library with a cup of tea and a sincere desire to grow. Training is not education. Training is adjustment. A model starts out mostly useless, a giant mathematical structure with numbers set badly, connections waiting to be shaped, and all the raw potential of a very expensive idiot. Then we show it data. Huge amounts of data, text, code, images, captions, documents, conversations. The cultural exhaust of an entire species trying to explain itself and mostly failing. For a language model, the basic training game is simple. Hide part of the text, ask the model to predict what comes next, compare the prediction to the actual answer, punish the difference, then adjust the model slightly so it is less wrong next time. That difference between what the model predicted and what the correct answer was is called loss. Loss is the machine's little receipt for being wrong. The goal of training is to reduce that loss, not to create wisdom, not to inspire character, just to make the wrongness smaller over an absurd number of attempts. The model makes a prediction, the system measures the error. Then, using a process called backpropagation, it works backward through the network to figure out which internal numbers contributed to the mistake. Those numbers are the weights. Then another process, usually some form of gradient descent, nudges those weights in the direction that should reduce future error. A little here, a little there. Millions, billions, sometimes trillions of tiny numerical humiliations. That is training. Guess, measure, adjust, again. Guess, measure, adjust, again. Until the model stops being obviously terrible and becomes quietly dangerous. Now the model is not memorizing every sentence like a clerk filing papers in a basement. At least that is not the goal. The goal is for it to learn general patterns. Grammar, style, facts, associations, reasoning shapes, code structure, how explanations usually unfold, how humans phrase certainty when they should absolutely know better. All of that gets compressed into the model's weights, not as neat little facts, as statistical tendencies. After enough training, the model becomes much better at predicting what should come next in many different situations. That is why scale matters. More data can expose the model to more patterns. More parameters can give it more capacity to represent those patterns. More compute lets training run through more examples and more updates. None of this guarantees intelligence. It guarantees expense. And if everything goes well, capability. Training also happens in stages. First, there is usually broad pre-training. That is where the model learns general language and world patterns from massive datasets. Then there may be fine-tuning, where the model is shaped towards specific behaviors, domains, or instructions. Then there may be alignment work, where humans try to make the model more helpful, less harmful, and less likely to respond like a feral autocomplete that found a legal loophole. Each stage changes the model. Each stage nudges the weights. Each stage leaves fingerprints on what the model becomes. So how does training actually work? Training shows a model huge amounts of examples, asks it to make predictions, measures how wrong those predictions are, and adjusts the model's weights to make future predictions better. That is it. Not magic, not consciousness. A long, brutal optimization process where math repeatedly tells the machine, no, less wrong, again. And after enough of that, if the money holds, the electricity flows, and the data is not complete garbage, you get something that can talk, which is apparently what we decided the future needed.